Okay, this is Dwight Goins with his final, and I want to talk a little bit about what my project is all about here, and clear it out. So I just sent a reset command programmatically to the device, and so here you can see it's connected to my Wi-Fi connection, the microphone is set up, and it's connected to a WebSocket server. And the device is utilizing a MEMS microphone, an INMP 441 microphone that's connected to the ESP board. It's also connected to a servo motor. It's connected to a LM microphone that detects just regular loud noises. It's connected to these 4 LEDs, connected to a thermal sensor, a light sensor, and those are all the sensors that are connected. So the thermal sensor is basically the same sensor connectivity that we did for the midterm. The light sensor is just for dimming lights. The loud noise detector is more of an alarm system, and the thought here is that whenever you make a large sound, then this will kick in and this will toggle a light. But this will also toggle the microphone. Right now the microphone is not on. So when the large sound happens, the microphone turns on and starts listening to where that large sound came from. And then what you can then do is you could tell this microphone, okay, maybe that sound came from the patio or the porch or outside, so turn on the light on the outside. So let me see if I can demo that. Okay, so I'm going to clear it so you can see the screen a little bit better. And I'm going to make a large sound. All right, so now the other microphone is turned on, it's listening. So I can say, turn on the patio. And so the patio light will show to allow me to take a clear look into what's going on. And maybe I've noticed something that my doors, maybe they're not, closed all the way. So I could say lock patio door, and it'll go ahead and lock the patio door by turning the server motor representing the lock on the door. The next thing I can do is, oh, another thing, so right now the audio is kicking in and it's getting all kind of words that I'm saying, and you notice that all the lights are flashing. That's representing that it's not understanding the commands that I'm saying. So whenever I'm saying things and it's trying to understand what I'm saying, it'll flash all the lights, not recognizing my commands. Okay, I'm gonna turn the voice off. Toggle voice. Alright, so here you can see that I've turned off the voice, so now the voice commands are not listening anymore. But again, if I were to make another large sound, then the sound would come in. And I think these are just some backcode events that are just coming in later. Okay, so we got the lock and unlock, we have the turn the light on. We also have the ability to turn on the temperature. Let me see if I can get my microphone back on. Sometimes it works, sometimes it doesn't. Alright, so now my loud sawing sound comes back, my microphone is kicked in. So now if I can go, it's getting hot in here, turn up the AC. Okay, so here it'll represent turning up the AC. It'll also take the temperature here and move it up some degrees so the AC would come on, right? And that's kind of the point of what the turn on the AC is. But if I had the DC motor fan, the fan would also kick in as representing, I've actually turned the fan on, I just don't have it connected because I can't control it because I don't have a DC motor controller. Okay, so that would be, turning on the AC or turning up the AC. me see. Maybe it's super hot and I want to turn down the heat. Okay, so here, same thing, when you turn down the heat, then it changes the number on the base temperature for the thermostat that represents turning down the heat. And the thermostat number is still representative of the red light. So let's say, now you basically, want to, I don't know, you want to turn on lights. So you want to turn on all the lights. So if the command gets recognized, all the lights should turn on. But if it doesn't, then it might be something else. Let me see. Turn on lights. So some of the lights came on. I think my blue and red lights, they probably flash on because they're also connected to the thermometer, and the blue light's also connected to the soundboard. So if I'm ready to say go to sleep, I can say turn off lights, and then all the lights in the house would turn off. Okay, and that concludes my demo of the different functionality here. Oh, by the way, you can also say things like, let me turn off the toggle voice. Okay, so what that also does is turn off the voice commands again. And so you can also tell it to do things like, I don't know why it's like it's batch. It's like 2 or 3 batches later than it kicks in. Unless it didn't turn off the voice. Okay. In any case, you could also say turn on the red light. This is Dwight. I wanted to explain a little bit about the code and what's happening. So the Arduino ESP32 code was done in Visual Studio Code with Platform I/O. Platform I/O is just an extension that you can run in Visual Studio Code that allows you to program to Arduino boards. It basically allows you to run sketch files, as regular C++ apps. And so that's what I started with. I actually started with Arduino, but the Arduino sketch file, when I started coding against it, this file got way too big, and I couldn't even load it up inside of the Arduino sketch. It said it was too big of a sketch file. So I had to pop over to the Visual Studio Code. But here you can see I have just all the necessary include files. I have some defines here for some numbers, and some parameters that I'm using, and some methods that have been pre-declared. And then, it's the same functionality. I have the setup method. I have the loop method. Those methods are still here. So the setup basically does all the setup of the Wi-Fi connection. I have this trim, left trim and right trim coding to trim my string, trying to understand, when I get the commands from the WebSocket server, I want to, well, actually, this is when I get the credentials to log into the WebSocket server. I need to trim some of the paths to pull out the pieces of information I need. Here's my main method that does all the processing. It's called the process voice commands method. It goes out and it looks for these different words. Right? Am I resetting the device? Am I toggling all the commands? Am I toggling the voice to turn off the voice recognition piece? Am I telling it to unlock and lock? Am I turning on the fan? Am I turning on the kitchen lights? Am I turning on the blue light? All the lights, bathroom lights. If I scroll down a little bit more, you'll see the thermometer setting, turn up the heat, and I have a turn down the heat, turn up the AC. I even had space for a speaker. If I wanted to connect up a speaker to play the speaker, I can turn that on. And this is just my little functionality here that represents, hey, if it's not one of those commands, I'm going to flash the lights a little bit and just say, hey, the command is not recognized, and pass in that command that came in. So here you can see kind of what the lock and unlock does. For this particular one, I'm not paying attention to which location but for the other ones, I am paying attention to the location. So based off of if the location comes in as the kitchen, turn off the lights in the kitchen, then the kitchen will be representative of a particular LED pin that's being passed in, and that's the one that I will turn on and off based off of that location. Okay, so that's kind of the code here for the Arduino. Now, to do the voice recognition, that is done in an Azure function, and that code is done inside of Visual Studio.net. So in Visual Studio.net, I have an Azure function that I wrote here, and the Azure function basically takes the message that came in, and it basically, reads some information reads some configuration information, and this is really where the main thing is. So whenever the Arduino board sends in messages, it's going to either send it in as a binary message in the case of audio samples, or it's going to send it in as text messages. So if it sends it in as a text message, then what I do is if the text message comes in with a certain prefix, such as a CLU prefix, then this was kind of my debugging and troubleshooting of my trained NOP model. So this, if it sends it in, then I send it through my NOP model to basically try and figure out what the intent and action is, and then I return that intent and action back to the ESP board. Right? And that's all this is really doing. It's a WebSocket server endpoint that just returns intents. And these intents can also have entities. So here you might see turn on lights. It might be turn on kitchen lights. It might be turn on bedroom lights. Right? So it'll basically be based off of these intents that are coming back. Now the intents are figured out through the natural language processing engine. And I'll show you that in just a minute. In any case, so this main code starts here at run, and this is the main method that gets called whenever the ESP board sends commands up. It sends and checks for binary messages or text messages. In the case of if it's binary, then it's an audio sample. Then I load up the audio buffer, and I basically keep loading it up to 4 seconds. I get 4 seconds of audio, and then what I do is I process that audio by running it through a resampler here to resample it to fit the 16,000 hertz, 16 bits, one channel that it needs to match in order to go to the Azure Cognitive Services to transcribe the audio. So that's what that's doing. So here is where I transcribe the audio. With this call, I take the stream and I push it up into Azure to transcribe the audio. So then I get the text back from that transcription. And then once I get that text back, then I pass it into my trained model to determine, again, what the intent is. And the intent is just the action that I've coded. All right. And then once I've done that, right, I pass back my intents and my entities, and that goes back to the ESP32 system. Okay, for my natural language processing engine, I had to train a model to recognize certain intents. So this was done through the Language Studio. So the first thing I did was I added some intents here to my Language Studio, and that's done by going in here, and I added some intents here, and these intents then allowed me to add some entities that I have. So I have a number of different entities: AC, fan, heat, lights. I have red light, blue light, green light, yellow light, freezing, right? So I added the intents and the entities. The next thing I had to do once I had my intents, I had to label some utterances. So for example, my intents were lock and unlock, toggle voice, turn down, turn off, turn on, turn up. Right. So these are my intents and my entities, and I had to label these with about 50 some odd utterances. So basically sentences. So for example, stop listening to my conversation. Oh, can you hear me now? Start back up listening, enable microphone, enable listening, enable voice, right? So just different words that mean whatever this intent is. So I had to label these together. And then I tested it against some unknown words with a testing set. And then all of that, I ran it against a training job. And within that training job, I set it to be a 20% split of training, the 20% validation set and 80% training set. Um, and then when I did that, that allowed me to get a model that had an 80% F1 score, 80% precision, and 80% recall score. I didn't do so well on my entities though. If you take a look at my entities, I got 70%, 57% of precision, and 91% of recall. So I can, go back and add some more entities and more training to get this bumped up just a little bit. But I had to, run the training model, run it for, a little while. Um, and after I've run it a number of different times, as you can see, I have 148 utterances I had to put in here. Then I got my percentage of my model. Okay, and so then once I did this, I went ahead and deployed my model up into Azure so I can use it inside of my Azure function. Okay, and so that is the natural language processing in order to pull down the intents and the entities such as the appliances and the locations. I'm not sure if I actually showed you all of those, but let me go back into that. So for entities, I have appliances and I have locations. So appliances are things like AC, fan, heat, light, speaker. For the location, I have things such as bathroom, garage, kitchen, patio. So you could say things like turn down the lights in the bathroom, and it'll know if you use any of these words, it'll represent the location. And I can use these words as the location inside the ESP to trigger a different pin to turn on and off a light. Right? So that's how the natural language processing engine works. All right. And that concludes the explanation of the CLU.